Good day everyone. Another last battle of the small amplifier. Small but relatively powerful compared to what was previously on the channel. Comparison with a match. Here is installed chip PAM8610, which according to the manufacturer's claim produces 10 watts per channel on a load of 8 ohms at a power supply of 12 volts. Not interesting at all because instead of a load of 8 ohms, we will have 4 ohms. Connecting the board is very simple. Input of the right channel, input of the left channel, ground between them. Then the output of the right channel, the output of the left channel. Here you connect the 12 volt power supply, plus and minus. Here you can solder a jumper or a switch to mute or put the chip in sleep mode. I would like to install a heatsink here to cool the chip, but since the board is sold without a heatsink, so we will test it in the same form. By tradition, now I'll listen to this amplifier for a while, make some conclusions about its sound quality, and let's get down to the most crushing and merciless tests. So as for the sound, I can't say anything bad. The detailing is good, the sound is assertive, bass is present with high and middle frequencies, also everything is good, but I didn't like one thing. It is very noisy. Now the amplifier is switched off. I switch on the power and can you hear the noise? And at minimum volume it's no fun to listen to. But all the better, it won't be a pity to burn it. But before that, I suggest you look at the datasheet. According to the chart, on an 8 ohm load, we get about 8 watts of input power into the channel at 12 volts, 9 watts from 13 volts. Power with 10% distortion. I don't even want to consider, as it is impossible to listen to music with such distortion. And with a 15 volt supply we should get 13 watts per channel. In order that the signal from the amplifier of D class could be considered by oscilloscope, on the output of the amplifier I attached LC chain, and now you can see quite a good sinusoid on the screen. Increase the volume. We see 6 volts of pure signal. 3649 watts per channel. That's at 4 ohms with a 12 volt supply. Now let's check the overheat protection. I'm turning it up to maximum power. The chip is already very hot and you can see that on the oscilloscope screen the signal disappears and appears. That is, without a heatsink, this amplifier is not able to operate at high power for a long time. The overheat protection kicks in. That's very good. It's there, it's worked several times, so we can't break this chip by overheating. We'll have to come up with some kind of cooling. We will use liquid cooling, more precisely, motor oil, as it does not conduct electric current and has a very high resistance and will not affect the operation of the amplifier. I immersed the amplifier board in oil. The power supply was set to 18 volts. Let me remind you that in the datasheet the maximum was 15 volts. And still the thermal protection is triggered. The output voltage is 8.4 volts. With a 19 volt supply, the output is 8.6 volts, raising the power to 20 volts, and that's the end of it. Did the amplifier burn out or did the overvoltage protection kick in? I lowered the voltage. Switching it on? Nothing, no signal. So we've successfully destroyed another amplifier. Maybe we should switch off the power. Yes, it's working, and it turns out it's a very reliable amplifier. The overheat protection has kicked in many times. Now I've exceeded the supply voltage by a lot, but it's still working. So what's our maximum power output? 8.6 to 8.6 for 18.5 watts per channel, and that's very good. This is the PAM8610 amplifier. No matter how hard I tried to destroy it, it wouldn't give up. This is not a successful edition of the last battle. Yes, it's noisy at minimum volume, but if you listen louder, you won't hear that noise. The sound quality is quite good. Well, and the most important advantage of it, it is immortal. The link to the amplifier board will be in the description of this video. Thanks for watching. See you soon.